Hey folks, 4.3 is area of a sector, and it's pretty straightforward. It's that same idea. Remember, if you recall, how I was telling you to kind of think about as far as arc length. Arc length deals with circumference, right? Circumference of a circle and part of it. So it's part of the circumference. So if we did something like, let's see, when I set up that ratio, I would say like that theta is to 360 degrees as S, whatever your S is to 2 pi r. S stood for arc length, if you recall. And so whatever your arc length is, and this could also be, or I would say theta is to 2 pi as S is to 2 pi r. And that was that little shortcut. So if you ever forgot the formula, you could always set it up because you could say part of the circle, the angle, or the arc length is to 2 pi as the outer edge is to 2 pi r, the circumference. So the same idea now with area. If we look up here, so we can say that area of an entire circle is to pi r squared because that's the area of a circle. If you recall, it's pi r squared. And then whatever that area is, that sector, that part, as whatever that angle that corresponds to that sector is to all the way around 2 pi. And it really is okay if you don't want to deal with radians. You can actually do this in degrees. So you could say area is to pi r squared. Let me change the pens there. As theta is to 360 degrees. So that works as well. Okay, so that's our proportion. This is the area of the sector right here, what I'm highlighting, this pink portion, okay? So whatever this angle is, so let's just for fun, let's say that looks like about 30 degrees, and suppose that R was 2 centimeters. So to find the arc length, I would say, okay, 30 is to 360 as area of my sector, in this case it's area of the sector right here, is to pi r squared. Okay, so I could cancel out that. I could cancel the 3 goes in there. That's 12 times. And I'm bringing the pi r squared over to the top. So I have pi, whoops, I didn't substitute r squared over 12, but I know that r squared, I should have just put it in right there, is, I said r is equal to 2. So then instead, let's just change that to a 2 squared, like that. So that's 4. 4 goes into this 3 times. So the area of this sector is pi over 3, which is approximately equal to 1.047 centimeters squared. Okay, so remember that's just the area of the sector. So the sector is this little bit chunk of the pie, as it's not the entire circle, it's just a portion of it. I just wanted to bring up that this area right here is the total area of that circle with radius 2, 12.566 centimeters squared. So really this is thinking about like a piece of the pie. If you know that this is total surface area, what portion of the circle are you dealing with? You're dealing with 30 out of 360 of that circle, which if like once again when we simplified that, that's only 1/12 of the circle. So if you took 1/12 of that 12.566 and divided it or multiplied that out, you would get this area. So I just want to remind everybody that it's not like it is a formula and you can set up the proportion, but it's not anything really new because we all have learned how to do in algebra how to calculate the area of a circle. Okay? It's just a chunk of the circle. It's a fraction of the circle. It's 1/12 of the circle. So if you solve this equation, back to this, and if you solve this equation for A, you're going to get this fun equation. So this is area is equal to 1/2 r squared theta. Remember, once again, just like with arc length, that theta is measured in radians, okay? So the only time, if you choose to use formula 4.5, you have to convert your angle into radians, just like, unless you do it this technique, the way that I showed you right here, where we set it up as a proportion. So here's another example of finding area. Just made up this problem. Find the area created by the minute and hour hand of a clock that reads 4. So here's the minute hand, here's the hour hand, 4 o'clock, excuse my drawing. So if we wanted to just use that formula, A equals 1/2 r squared theta, we could figure out what this theta spans. Now it doesn't specify if it's this area or this area, so we'll just find both of them, okay? So in the first situation where this is our theta, if you think about it, how many hours are in a day, or in the clock? It spans 12 hours. So, and we know that the full rotation in radians is 2 pi. So if we do 2 pi and then we divide that by 12, that each hour, we could say each hour measures pi over 6 radians. So how many hours do we have? We have 1, 2, 3, 4 right there. So that's equivalent to 4 pi over 6 radians, which simplifies to 2 pi over 3 radians. And, oh, and I didn't tell you what the length of the minute hand reads. So the minute hand will just say it reads 5 inches. So if the minute hand reading 5 inches, now I can say that the area of the sector, just a little subscript there, is 1/2 5 squared times 2 pi over 3 radians. And if we type this into our calculator, we will get that this is approximately 26 point, we'll just say 18. So 26.18 inches squared. We're dealing with area now, not arc length. So the area that this spans is 26.18 inches. Okay, now if you wanted to find the area of the rest of it, well, you could count it all up, or you could just say pi r squared, which r is 5, so let's just write pi times 5 squared. That's total area, minus this 1/2 5 squared 2 pi over 3, which in my calculator I got about 52.36 inches squared. Sometimes arc length is more applicable in these types of situations, so we might, to come up with a area of a sector in terms of arc length basically and the radius, it's easy to do because if you recall from 4.2 that arc length is equal to r times theta. And so theta, that implies that theta is equal to s over the radius. So if I just substitute this in for theta, that's how we get 4.6. So area equals 1/2 r squared, and that's s over r, and that cancels out one of my r's. So a new formula for area of a sector is 1/2 r s. And so you have a couple of problems where they give you the radius and the arc length, and so that's how you would calculate the area of the sector. So I wanted to point out that numbers 4 and 5 in your assignment, in your practice problems, are very similar to 411 in the examples of the section. And you're supposed to find area. Remember before we found the distance around, the length around, but now we're finding surface area, or area enclosed by the belt. So when you set up your two circles and label all of your different radii and such and sides. The way to find this angle right here, I just want to remind you, this angle is similar, and I showed this in the last video. This is the same measure as this angle, so angle ABC. And to find that, I have a triangle, and I know in this case this is my right triangle here. And I know that this angle, by just dealing with right triangle trigonometry, I can say that let's see, are we dealing with opposite and hypotenuse? Because this is 6 root 6 and hypotenuse is 15 of this angle, this reference angle. So I can say that the sine of angle ABC is equal to 6 root 6 opposite leg over hypotenuse 15, and so that implies that sine inverse of 6 root 6 over 15 is equal to, and they already calculated for us in radians, 1.37. You can verify that with your calculator. It'd be a good idea. So you've got this angle, 1.37. You can get this one by subtracting 1.37 from pi, and that would give you this angle right here, because remember, this whole span right here is 180 degrees, or pi radians. All right. So once you have the angle, you know the radius of this circle is 5. You know the radius of this circle, excuse me, the radius of this circle is given to be 8. That makes more sense because it's 3 plus 5. The radius of this circle is 5. So that's all you need to find the area of the two sectors. And so they break it down for you. They say, I just need to find the upper half of this. And if I find the area of this sector right here, plus the area of the rectangle, which is right, you can see that. That's just length times width right here. So 6 root 6 times 5, plus the area of this right triangle. The right triangle is right here. And the right triangle is just because it's a right triangle 90 degrees, it's just 6 root 6 times 3 divided by 2. And then the last section is the area of the sector, this last sector here, which is sector GBF, they call it. And then if I add up all of those areas and multiply it by 2, I'll get the total area enclosed. So your questions are very similar to that. So I didn't assign any problems dealing with segments or other angles other than central angles, because what we're dealing with and what you're going to deal with are central angles. They come out from the center of the circle, so these are central angles. But you can have all types of different applications. This is an angle that extends out beyond the center. What you can do, though, which is pretty neat, is you can always, whatever this length is, A, and whatever B is, you can always, from these 2 points, construct the radius here and the radius here. And you can actually find, so the radius is here, this is R, this is also R. If you recall from chapter 2, you can actually find the triangles. You can find the area, this one, area 1, and area 2, using Heron's formula, because you've got all 3 sides. And then you can find this by calculating whatever this angle is, theta, and finding the area of this sector right here. So I just wanted to point out that is something that you're very capable of doing. I didn't assign any problems, but I recommend you look at it. You might see it somewhere in another science or math class in the future, but you can review it then. And then they break down a formula, the area of angle OAB, which is, in this case, this little segment or part here, they're taking this and they're saying it's equal to 1/2 r squared sine theta. What this angle is, not the angle, but this little segment, they call it a segment, this part from here to here. Sometimes that's handy to know. And this is the formula if you ever need it, which I don't expect you to memorize, but you could look at some of the problems, and this is how they derive it. So it's not anything new or too tricky. I just figured that you had enough signed for this section, and then also 4.2. So that concludes the end of this lesson. I think it's pretty straightforward. If you have any questions, let me know. Have a great day.